Every galaxy within 300 million light-years of us is moving in the same direction. Not drifting, racing, 600 kilometers per second toward a single point in the sky. For 40 years, astronomers called it the Great Attractor, a concentration of mass so enormous it was dragging 100,000 galaxies toward it, including ours. Our team just proved it doesn't exist. The Great Attractor is an illusion. But that's not the strange part. The strange part is what they found instead. Something hiding behind our own galaxy that's bigger than anyone expected. In the 1970s, astronomers started mapping how galaxies move, not just the expansion of the universe carrying everything apart. That's the Hubble flow. On top of that, galaxies have their own motion, drifting toward regions with more mass and away from regions with less. These extra motions are called peculiar velocities, and when astronomers mapped them, they found something unexpected. Thousands of galaxies across a huge region of space were being pulled in the same direction, toward the constellations of Centaurus and Norma. In 1987, astronomer Alan Dressler measured the peculiar velocities of hundreds of elliptical galaxies. The pattern was clear. There was a massive concentration of matter pulling everything towards it. He named it the Great Attractor. The problem was that this region sits directly behind the thickest part of our own galaxy. The Milky Way's disk, all of its dust and stars, blocks our view in that direction. Astronomers call this blind spot the zone of avoidance. It covers about 20% of the sky, and the Great Attractor sits right in the middle of it. We knew something massive was there. We could measure its pull. We just couldn't see it. In January 2026, a team led by Richard Stiskalek at the University of Oxford published a study that changed the picture. They used a simulation suit called Manticore Local, a set of digital twins of our corner of the universe built from real galaxy survey data. Instead of asking where the pull is coming from, they asked three specific questions. First, what explains the speed and direction of our galaxy's motion through space? Second, where do the flow lines of nearby galaxies converge right now? And third, where's the Milky Way actually heading in the long run? The answers didn't match. On the first question, they found that all the mass within 500 million light-years of us accounts for only about 72% of our galaxy's speed, and the direction is off by 38 degrees. No single structure, including the supposed Great Attractor, dominates the pull. On the second question, where galaxy flow lines converge depends entirely on what scale you're looking at. At small scales, everything flows toward the Virgo cluster. At intermediate scales, the convergence point shifts to the Hydra-Centaurus region. At the larger scales, it moves further out towards the Shapley supercluster. There is no single attractor. And on the third question, where the Milky Way is actually heading, they ran the simulation forward to the far future. The dominant pull is toward Virgo, but even Virgo accounts for less than a third of our motion. Their conclusion is direct. The classical Great Attractor is not a real structure. It's an artifact, a trick of how we measured the velocity field at one particular moment in time, and at one particular scale. So, the Great Attractor is dead, case closed. Except, the man who named it 40 years ago just fired back. In April 2026, Alan Dressler published a new paper. The same Alan Dressler who named the Great Attractor in 1987. He used the Magellan telescope in Chile, a near-infrared camera called 4-STAR, to measure distances to 66 galaxies in the Great Attractor region. The technique is called surface brightness fluctuations. It measures distances with about 5% accuracy, which is exceptional in astronomy. Most methods are far less precise. Dressler's data tells a different story. He found a strong, coherent flow of galaxies over a full steradian of the sky, That's about 1/12 of the entire sky, with peculiar velocities peaking at roughly 1000 kilometers per second, all converging to a point about 230 million light years from us. The size and direction of this flow match the original Great Attractor model from the 1980s. They also match the cosmic microwave background dipole, the most precise measurement we have of our motion through space. Dressler's argument is that simulations like Manticore Loco depend on galaxy catalogs that aren't accurate enough near the zone of avoidance. The real universe has structure there that the simulations miss. His distance measurements, precise, direct, and observational, show the flow is real. So one team says the Great Attractor is an illusion. The man who discovered it says that the data proves it's real. So this isn't settled. And then a third team found something that makes both of them look small. In March 2026, a team led by René Kraan-Korteweg at the University of Cape Town used the Meerkat radio telescope in South Africa to peer directly into the zone of avoidance. Meerkat detects hydrogen gas at radio wavelengths that pass straight through the dust, blocking optical telescopes. They combined radio observations of over 2,000 galaxies inside the zone of avoidance, with peculiar velocity data from more than 65,000 galaxies to build the most complete map of this region ever made. What they found is enormous. The Vela Supercluster, first identified in 2016 but never fully mapped, is far larger than anyone thought. It stretches 300 million light-years across, sits about 800 million light-years away, and contains roughly 34 times 10 to the 16 solar masses. That's 34 million billion suns. Vela rivals the Shapley concentration, previously considered the largest structure in our neighborhood. It exceeds the mass associated with Laniakea and the Great Attractor region, and it has double core, two massive concentrations of galaxies linked together behind the thickest part of the Milky Way's disk. The team gave it a local name, Vela Banzi, from the isiXhosa word meaning revealing widely. An apt description for something that was always there but never fully visible. The structure is gravitationally significant. It's competing with the Shapley concentration and whatever exists in the Great Attractor region for influence over the motion of galaxies in our part of the universe. Part of the pull we attributed to the Great Attractor may actually come from Vela. Here's the honest picture. 3 teams, 3 results. None of them fully agree. Stiskalek simulations say no single structure dominates. The Great Attractor is an artifact of scale-dependent velocity measurements. Dressler's direct distance measurements say a coherent flow toward the Great Attractor region is real and matches the CMB dipole. And Kraan-Korteweg's radio survey reveals a structure behind the Milky Way that's massive enough to reshape the entire picture. What everyone agrees on is that something is pulling us. The Milky Way, the local group, the Virgo cluster, Laniakea, all of it is moving at 600 kilometers per second toward a region we can barely see. The disagreement is about what's responsible. The zone of avoidance is the bottleneck. 20% of the sky remains partially hidden. Until we can see through it completely, the answer stays incomplete. Meerkat cracked it open. The square-kilometer array, currently under construction in South Africa and Australia, will go further. There's something unsettling about knowing that our entire galaxy is being dragged somewhere, and after 40 years of looking, we still can't fully explain why. The Great Attractor might be real. It might be an illusion. Or it might be one piece of something much larger that was hidden behind our own galaxy the whole time. We're not passive observers in this universe. We're participants. Every star in the Milky Way, including the Sun, is caught in a gravitational current that stretches across hundreds of millions of light years. and we're only now starting to see where it leads. If this one was worth your time, a like genuinely helps the channel grow. Subscribe if you want more of these. Thanks for watching. Clear skies.